Now we want to compute the following value of this integral. Our function is 1 over x squared minus 2, and the lower limit is 8 and the upper limit is 10. We see that 1 over x squared minus 2 is bigger than 0 in this interval, 8, 10. So therefore, we can interpret this value as an area. Okay, when we have this kind of fractions, we can decompose them in the following manner. We have 1 over x squared minus 2 can be factored as x minus square root of 2 times x plus square root of 2, which we can rewrite as a over x minus square root of 2 plus b over x plus square root of 2. We cross multiply, and we're gonna do some identifications. Here, if we cross multiply, we're gonna get a plus b times x plus square root of 2 times a minus b over x squared minus 2. We'll see why I had to write x squared minus 2 again. So we have 1 over x squared minus 2 is equal to this one. Here, we see that we have two fractions that they look the same, okay? The numerator and the denominator. So we have to identify and make the coefficients the same. Here, we see that we don't have an x here. Therefore, we need to have a plus b equals 0. So to make these two equal, we have to have the same coefficients. And we need to have the square root of 2 times a minus b equal to 1. Okay, if we divide here by square root of 2, we're going to get, on the top, we still have a plus b equals 0. And here we're going to have a minus b is 1 over square root of 2, which is square root of 2 over 2. If we add these two equations, we get 2a is square root of 2 over 2, and I get a is square root of 2 over 4. And from here, I get the b. Because this equation, a plus b is 0, it's going to give me b is minus a. Minus a, that means minus square root of 2 over 4. Therefore, I can go back here and replace these two. So I have 1 over x squared minus 2 is square root of 2 over 4 times 1 over x minus square root of 2 minus square root of 2 over 4 times 1 over x plus square root of 2. Okay, I can put this one as a common factor. So I have square root of 2 over 4, and I have 1 over x minus square root of 2 minus 1 over x plus square root of 2. Now I can integrate. I can integrate 1 over x squared minus 2 dx. So first, I keep this one as a constant, square root of 2 over 4, and using linearity, I can write this one as the integral of 1 over x minus square root of 2 minus 1 over x plus square root of 2. And now a primitive of this one, okay? So I get square root of 2 over 4, the natural log of x minus square root of 2, and here I get minus the natural log of x plus square root of 2. All I need now is to add I can add a constant here, so plus some c. But I can go back here and I can put 8, 10, 8, 10. When I do this, I put it here between the bracket to evaluate. So when I do the evaluation, I'm going to get square root of 2 over 4, the natural log of 10 minus square root of 2, minus the natural log of 10 plus square root of 2, minus the natural log of 8 minus square root of 2 plus the natural log of 8 plus square root of 2. I could have done something better. Here, I could have written this one as the natural log of x minus square root of 2 over x plus square root of 2. And I can do the evaluation between 8 and 10. Okay? So when I do this, I'm gonna get the natural log of 10 minus square root of 2 over 10 plus square root of 2 minus the natural log of 8 minus square root of 2 over 8 plus square root of 2. I can simplify this one more, make it easier, but for me, that's all I need, okay? That's all I need for now, because our aim is to just see how we can decompose a fraction and get these coefficients. We're gonna come back to these fractional decompositions and we're gonna study all the cases. This is just a simple case to see what we can go. And using the calculator, we can evaluate this one, but that should be the last step. We do this one by hand. It's good to do it by hand. And I think that's all we need for now.